Little Red will take you back.
All right, thank you. Wow, fantastic presentation. It's a hard one to follow. This is work that was part of my dissertation at the University of Pittsburgh. Um, I'm not going to lie, like a lot of this work was actually inspired by that Rolling Stone article that Justin published a few years back. My thesis advisor did the analytical work that was used in that article, or some of the analytical work. So that's kind of where we got this idea. And so, not to reiterate too much here, but naturally occurring radioactive materials in produced water. With the context of the Marcellus, there's just, as he said, a lot of stuff in there. There's some dissolved uranium. There could be some thorium. There could be potassium salts and things like that. But for the purposes of this presentation and modeling and stuff that we did with relation to this, we're referring to the radium that's in the water. Radium is a child isotope of either uranium or thorium. Primarily, there are two enriched isotopes in produced water. They're longer lived. Radium-226, which comes from the mineral uranium content of the formation, and then radium-228, which is a decay product of the thorium that's in the formation. And radium-226 has a half-life of like 1,600 years, so that's like going to really accumulate and move around, and those are like legacy waste that we would have at the surface if there is an exposure. And elephant in the room here, Justin had mentioned this, as we had this thought experiment last year. We mined, I'll talk a little bit about this, the data source for this, but we had all of this data, and we were throwing out some hypothetical beneficial uses and just seeing what was in there, and we just found a lot of lithium. And we just published this paper, and it took off, and now there's a whole industry working group that exists, postulating possibly extracting lithium from Marcellus produced water. There's a lot of lithium in the water, so it's a veritable gold rush right now. We did not anticipate that either. So the results suggest you can get somewhere between 2 and 3 tons of lithium per Marcellus well. Annually, that can culminate to somewhere between 11 and 1,200 metric tons. Which is, it's kind of one of those situations where it's like terrible regionally, but it has a larger global impact, right? Because we could make a lot of batteries with that. So that was our idea, anyways. But with that sort of context and thinking about, well, like, what is the realized actuation of that? We wanted to better understand the environmental costs of the other stuff that's in this produced water. Particularly, if you're going to extract lithium from the Marcellus produced water, you have to process it even further than trucking it to a disposal well where you might have evaporation reactions and things like that. Like most of the technologies that are used to extract direct lithium are referred to as direct lithium extraction. It is not direct lithium extraction. There involves a conditioning or pre-treatment of the brine. There's a lot of iron and barium and radium and other things in there that you have to remove before you can pass it through your DLE tech to effectively remove the lithium. And so that preconditioning, this initial treatment from a raw brine to a chemical treatment, is where you would generally produce most of the norm residuals. Some of this process happens in the tanker trucks and in the tank batteries that are storing the fluid. This is the sludge that they clean out, right? It's like barium and things precipitating out. And so what we wanted to do is, with this project, is essentially get a better idea of how much radium is in the water. What is the realized picture? Like the most authoritative study on this was published in 2011 using data collected from 2009 to 2010. And so there have been a lot of wells drilled across the state. So the spatial context of this issue has expanded, right? And we know that the reservoir is heterogeneous, so it's not compositionally the same across the whole formation. So we wanted to see if like maybe the mineralogical content of the Marcellus would impact the radium that's in the water too. So do these do radium activities vary spatially across the state? As others have reported, are the activity ratios, so those two isotopes that I had mentioned, are they still, in context of a larger data set, do they still hold up as a pretty good tracer for spills or processes that are happening after the water has been removed? And then in the case of lithium extraction, what's the potential mass and radioactivity of the waste that we would generate from this if we were going to treat all of the water and cure the nation's battery woes? And so the source of this, this is kind of the probably the higher level impact of this, the work that went into this is we spent better part of 2020 both remotely and with masks in DEP offices across the state collecting hard drives and paper PDF copies of Form 26 chemical analysis of residual waste. So this is a compliance chemical analysis compliance report that's submitted to the state of Pennsylvania for every well pad, every registered waste generator site across the state. And it has a pretty exhaustive list of chemical analytes, of which lithium and radium, as well as the toluene and benzene and all of the organics. And so we mined all of these data sets. We applied some chemical criteria. We were really only concerned with, it's just messy. It's disparate public data. So we wanted to make sure we were looking at produced water. So not like lower TDS flowback water, not cuttings leachate data. I mean, there's value to that too, but we were specifically focused on produced water. So out of 2,500 of these reports that we mined, we have roughly 654 chemical analyses spread across 553 wells spanning the state. Just to give you kind of an idea of this is like the inorganic and residual oil and grease residual analyte list that's included on there. There's actually a lot of these reports have additional analyses that are available. But of note is we have most of the major cations and anions. We have lithium, we have radium, and so we're able to apply some mass balance and charge balance errors and stuff to make sure that the data is what it is. And this is just a histogram of the results of the total radium activities that we've pulled out of these. So in blue is the new data, and in orange is the previously published data. And we can see that those two sample populations are different. So how different are they? Well, so we're looking at on your left is a box plot of all of the data available in the USGS National Produced Waters data set that had radium activity data and TDS. And so these are all, radioactive fracking waste classified brines that are greater than 35,000 parts per million. So they're really salty. Just so we can have an apples to apples comparison. There are samples in there that have lower radium counts. There are samples that have higher, well, not higher, but for the most part, if it's a brine, it's included in this box plot. And we see that, again, one of these distributions does not look like the other. So the first box that you see right here, Marcellus additional, is the new data that we've mined from these residual waste data sets. And then the previous distribution of radium measurements from Marcellus is the next smaller box, compared with other shells in gray and then other conventional formations in yellow. And we see that the the median is higher than previously known, and the maximum values, like, it's ridiculously high, 41,330 picocuries per liter. It's like, to my knowledge, one of the highest ever recorded radium activities from a domestic brine. And we haven't even mined all of the data yet. So this is just that one. So for our analysis, we combined the previous Marcellus data with this newly mined data set and applied our statistical and chemical QCs. And we have a pretty robust picture from 674 samples across 561 well pads in the state. And this is just kind of how those distributions look when you break them out into histograms. Separately, we see that we have big fat tails in both total activity and then the individual isotope activities. If you look in this kind of the lower left histogram, those are the radium isotopes, 228 over 226. And interesting enough, it is still narrowly constrained despite the large spatial spread of the data. If you plot this up, we're looking at the total radium activity versus the total dissolved content of the water from both the Marcellus, which is in red, to previous Marcellus samples in black. And then the circles and triangles are other shales and other conventional formations. We see that generally the higher the TDS, or the saltier the water, the more stuff is in the water. Naturally, you have more radium in it. So that's kind of the first overall broad trend. Second, obviously, you can see that the Marcellus total radium activities from produced waters in the state are higher than other formations, orders of magnitude higher per relative or normalized to total dissolved solids content. So that's takeaway number one. Takeaway number two is this data is spatially referenced, so we're able to start mapping things. And this is still relatively in its infancy. We're trying to tie in some other spatial, structural, and surface shapefiles so that we can do a proper spatial regression analysis. But for a high level takeaway, we plotted all of our data. We did an ordinary CRIG, so that's just a statistical computation to see the probability of a concentration, a radium concentration relative to a known data point. And then we divided those statistics up into equal area quadrants. So if you look at a full pick map of the Marcellus, you notice that it's very linear. So we have a northeastern quadrant, a north central quadrant, and a southwestern quadrant. And clearly there are different radium distributions depending on where you are spatially within the state and in the formation. The Northeast has some of the highest values. The highest recorded value is found in the northeast part of the state, the northeast quadrant. North central part of the state we have the fewest data points there, unfortunately. We only have 45 data points, but we still see comparable maximum values and actually a higher medium value in the northeast. And then the southwest it's roughly half of what you would get in those other two regions. So there's still more to parse out here. There may be a structural or geologic component to the enrichment of radium in these fluids, and it's an interesting corollary that connects the subsurface to environmental issues at the surface. So that's kind of where we're exploring. So we take all of that can't let this out. So again, this is looking at the radium activity ratios, so the isotope activity ratios. So we have that shorter-lived radium-228 isotope. You divide that by the longer-lived radium-226 isotope, and you get one of these ratios. Broadly, because of that formula, because you're dividing the smaller concentration by the radium-226, the larger concentration, the ratios decrease with total radium activity, as we kind of see in this chart. But important takeaway is that 90% of our data, this new compiled data set, has these activity ratios are less than 0.32, which is like fairly robust at distinguishing it from Utica and Point Pleasant brines in the basin. And so it could be a fairly robust environmental tracer, either in landfill leachates or for spills. And then just kind of like probably less interesting to this group, but the radium is the ratios are roughly in disequilibrium with the we would infer from the mineralogy of the formation. So again, there's possibility that this radium bearing fluid is migrating into the formation, or we are intercepting this fluid through fractures from somewhere else. So that's kind of that's future ongoing R&D needs to be done to parse that out. And so what does this mean if we're going to start treating this and extracting lithium from this fluid? We've heard about all of the horrible things from Fairmont brine. And it's like really, I think as a whole, from like an R&D standpoint, um, I was shocked when I learned about that because at like as an academic from a research perspective, we're still like trying to solve this first chemical pretreatment step. And so the fact that 10 years ago people actually had implemented this and they were brazen enough to just go and do it is like kind
They're
of
doing it today. I
yeah,
mean, right? It's still happening.
yeah.
You know.
Yeah, it's wild because there's still a lot of like just fundamental R&D to make these processes safe, and there's obviously the occupational health and safety standpoint of it too. So to calculate like what is the mass of like if we were to treat all of the extract, supply 40% of the nation's lithium from Marcellus produced water, what are the residuals, the treatment residuals that would be created using the most off the shelf economic industry staple that's being applied today, which would be this chemical pretreatment. And this is the case in Appalachia. It's probably different in the Permian Basin or the Niobrara or other places where they're working with these fluids. But we have a lot of sulfate. We have a lot of acid mine drainage. We have coal flue gas desulfurization effluents. There are all these waste streams that we could use to drop out some of the divalents and the radium in this chemical precipitation step. But just because it's the cheapest way to do it doesn't mean that it's necessarily the best way to do it. So assuming that model, and this is, you can't address everything in one paper, right? We're assuming that the chemical treatment of the raw brine is going to be via this sulfate treatment. And so we're assuming that the sulfate is going to be added quantitatively. So we're only using the moles of sulfate that we need to drop out all of the moles of barium, and then thus the radium. We're assuming that we're applying this to all of the 10 billion liters of raw brine that the state is currently existing at the surface annually. We're assuming that 100% barium is precipitated, 100% of the barium is precipitated out as radiobarite. All of the radium is incorporated into that, embodied in that mass of radiobarite. And this has all been kind of verified through a literature review. These are all published assumptions that have been peer reviewed.
No, because I know the worker here had something to say, because literature review is great, but did y'all? No, but he had a question, because he's done that process. He's actually done that process.
Well, we can discuss that.
Yeah, well, we can.
Okay.
Yeah, I'll wrap up here.
Okay.
All right. And so this is what, if you take all of that data and you combine it, we generated, so to randomize this, we used a Monte Carlo method, Monte Carlo framework, and that's a way that we can quantify the uncertainty on those big fat tails that we had saw. We generated randomized distribution using SciPy's Gaussian KDE function. So we did some computational analysis, and then we used those random values. We did sample pulls from each random value to plug into this equation, these two equations that you see here, and to come up with both the mass of radioactive sludge that would be generated for chemical treatment and the radioactivity of that sludge. So the results, it's pretty broad. The median of our simulation results is about 100,000 metric tons of treatment residuals per year. And that's kind of a best case estimate because this is all based off of our barium content in the water. Depending on the amount of barium or the regional location, the spatial location of where you would treat this, it could go anywhere up to almost 500,000 metric tons of waste per year. And the radioactivity of that waste is it's significant. It's 850 picocuries per gram. And again, there's a pretty broad trail and distribution on that. So we go from 30 anywhere up to 95,000 picocuries per gram. And to put that into context, the U.S. Department of Transportation criteria for transporting this is about 270 picocuries per gram. So the actual mass that is after they have to dilute it down before they transport the treatment residuals is going to be about 3 times more than what is actually generated from the process. And they're going to have to transport it because it's not there are no RCRA Class D landfills in Pennsylvania, so everything has to go out of state. So that's just a summary slide of new activities or new old activities. And they're higher than previously reported. The ratios are fortunately narrowly constrained and distinct from other waters. And the solid waste generated will be substantial and have a higher activity ratio. So, thank you. Yep.
Thank you, Justin.
Okay, we have a couple of questions from the audience, and the first one is kind of a curve. Yesterday's Post-Gazette had an article suggesting that the uh, wells that have been drilled and have ceased producing be converted to geothermal wells. I guess the question to the panel, do you think that's a good idea?
Yeah. Before we get to that, this gentleman, it's a great question, but he dealt with the process. I mean, one thing to me, and the research is so important because that amount of waste is incredible. But it's like, do you visit the facilities? It was like you were surprised there was one facility doing it. There was hundreds of facilities across the Marcellus doing this. We have a gentleman who worked at it, so I just want to have him ask about the process.
And when you were saying with the sulfate treatment,
Can you speak in the microphone?
I'm sorry, were you adding like a sodium sulfate to it
That's what, I
to
mean,
precipitate out?
Yeah, we would have. It doesn't really matter the source of the sulfate. Well, I guess there would be, if you're adding AMD, then you would probably have like iron residuals and stuff. So we were assuming we just use sodium sulfate and just so the mass balance was easier.
And that's the way ours started out, with sodium sulfate to get some of that to drop out. But then as we ran it through our evaporator, we were getting a lot of scaling, a lot of clogging of our heat exchangers. So they decided to add like a flocculant and a coagulant to it, run it through a lamella clarifier, even run that through a filter press. And that's where we started getting into the outrageously high radium concentrations. The cost efficiency of having to ship all that out to either Michigan, Utah, Nevada, just it wasn't cost effective of what we'd have to charge per barrel to clean that up. So that's just the main thing I was wondering if that's where you guys were leaning into.
Well, this was all kind of a thought experiment here. This was all just based off of data. So I think.
Well, that's the problem. Your thought experiment, which was funded by industry money, was published in Nature, the most reputable scientific journal in this country and really the world, and broadcast across world media, AP, Reuters. It was great you got the attention, but the takeaway was we can treat fracking wastewater and take lithium. Now, your thought experiment did not visit the plants that had tried to do it or talk to the gentleman like Sean.
Well, look,
I just want to clarify that it wasn't funded by. It wasn't like
The
industry
National
brought it up.
Renewable Energy Lab?
So it was a pit study. I was a graduate student. I did not understand that it would take off the way it did. I
and
don't know.
in all respect, and again, the situation, I collaborate with his PI. We've been trying to call attention to the amount of lithium in the produced water as an indicator. And now you can't deny the fact that the lithium is there. And why I'm saying this is I have looked at thousands or hundreds of data analysis, actually thousands of reports, etc., and lithium is not mentioned. And so again, this is something that ties into why that this is important to bring this to light. But of course, you understand, and this has been the problem from day one for the industry. It's putting you guys at risk because you've been never told that what you're dealing with is highly radioactive. I deal with landfills. I'm arguing with judges now because they don't think it's a problem. Okay? So, and Justin, just a question. How does your current study compare with the PAT norm study?
It's about twice as high as what they have reported. So
Yeah.
That's what it's like with the Marcellus. It's like there's like full transparency there. I'm not like an industry, schlub trying to, I didn't make any money off of that lithium paper. I was just a purely an academic experiment. And then it was, like obviously people saw a gold rush. So we find it like very important to communicate the other side of that so that people aren't being like, it's not a Fairmont Bryant scenario because people are going to be like, they're going to know that there's like radium in these and there are going to be treatment residuals and it's going to be this huge problem that they need to think about and plan. It's not something that they're just going to try to sweep. They can't sweep
Have
it.
you seen how this industry operates?
Well, hold on, Justin.
Richard had something to
No,
say.
I want to ask,
Richard,
how,
let him say it. This guy came very long and very far.
Let me ask you, what PPE were you using when you were doing this stuff? What kind of protection did you have?
So look, hey, I'm not trying. I'm not.
I was in this shit for 10 and a half
so has the
years.
industry changed?
No goddamn mask. I was wearing basically nothing. What did you have on?
I just had a conversation with a group of water operators, like trying to get information on solid wastes disposal for this paper. And I asked them if they were wearing dosimeters, and they said no. And I told them they should be wearing dosimeters.
What were you wearing?
Well, I haven't touched any of it. This was all.
Did you have a mask?
It was like, at work, I wear a dosimeter, but yeah.
So
we weren't giving a shit.
So to you guys, and this is a question, has the industry responded? Are you now getting the proper training or is it still being ignored?
It's still the same way. They don't look at the radiation. They don't give you any mask. You get a FR shirt from some companies, unless you got to buy it yourself. You get FR pants unless you got to buy it yourself. And then they want you to buy your boots, which are basically, they're nothing. You can either get your own, which are rubber, or you can get, which got to be steel or leather. Now they will supply you with a hard hat. They will supply you with safety glasses, and they will give you gloves, metatarpal gloves, because my God, you got to protect your fingers from getting smashed, but they're cloth. They suck in the water. They're not a chemical resistant glove. Now, you will get a face shield at some companies. Anterra requires a face shield in case you get a splash. They don't want you to get it on your face, but you can have it on your hands and your feet all fucking day long. And you can take it home with you. Wash it with your wife's clothes. Wash it with your kids' clothes. Take it in your car with you. Let your kids be in the car that you drive. No, we're not giving anything.
Okay, thank you.
Now, how do you get the radon out?
Radon's
That's just a question I asked. I mean, for filtering this stuff, how you get the radon out?
Which, by the way,
and I'm not a chemist.
Radium-226 decays to radon-222. I have some aqua salina in my lab, which is a de-icer that was produced by a company in Ohio, and it's a radon generator. It has over 1,000 picocuries of total radium in the product itself, and sits in my lab and generates radon.
Not to stop you, here's what I want to go on with. Okay, DEP and EPA and your health department was at Fairmont Bryant doing their testing. They had on their protective gear, their footies, their masks, and they were only there for a few days. We were in it for years. Why? If it wasn't so bad, why were they in their suits for a few days, but we're in it for years and not given anything?
So
now, what does this do to you? What do the isotopes do to you? No one's ever told me, because I don't think there's been a good enough study on it, is there?
Oh, there's.
I mean, is there a big study, but is it out?
The question is, though, how do you get the industry to respond? Because that's another question that was asked.
But this is where I would take issue. The question is, you've got research trying to say, oh, we're going to take all these great things, and Fairmont Bryant, Clearwater, they said they were going to make a product called Taste of the Marcellus. It was going to be edible salts from the fracking waste. There's another company that's making pool salts. We're dealing with them right now. They've left an idled site. And yet, who is doing the research on this? That's a pretty cool thesis paper too, I think. Look at their health harms. We do have the science, like you said, to look at that. Here are the guys. We know the levels. Talk to them.
Now, listen, I'm not against fracking. I'm not against this industry whatsoever. I believe that we need the jobs and we need the resources. But I think that they're going into it way too hard, way too fast without the knowledge. Period. Slow it the fuck down.
Okay, and with that, on that note, we need to take a break for lunch. We're going to have more presentations this afternoon. And of course, again, we're here to think about solutions. How do we get the industry to respond? Because at this point, there's still more people that are in harm's way, both in the communities and the workers themselves. Thank you, and grab some lunch, and we'll be back here at